So in this last section of Module 7, we're going to look at a few fundamental data structures needed for creating complex data sets. So in particular, we are going to look at how to build arrays. So from um, basic single variables, we can build sequences of those as an array. Um, as a type, we're going to look at characters and how those are represented in a computer. Strings are just sequences of characters. There is a way of creating aliases for the new types that one is creating through composition of the basic ones. And then we're going to look at some of the basic principles of coding styles. This last part is not something that we'll just do a class about, but it's generally what you need to learn throughout the class. There are really three basic principles. One is that, and maybe it's the most important, is that code has to be readable by humans. This seems to be counterintuitive, and people tend to write unreadable code with the intention of writing something that the compiler can understand and hopefully to make it faster. That it's a natural but really misguided tendency, because code is really a living, breathing thing, and as soon as it becomes hard or impossible to read from a human, that's kind of the kiss of death for that piece of code, and it will soon be replaced by something else, maybe a worse code. So it's very important to think in terms of if I'm writing something, there should be another person that will read this later, and that person needs to understand the code as easily as possible. By the way, another counterintuitive thing is that if that person that reads the code later is me, I will remember why I wrote things in a certain way and so on. So that will stay forever intuitive to me. Unfortunately, practice shows that after actually a fairly short time, looking back at a piece of your own code, it's also very, very challenging. So think in terms of writing code for another person that has no much information about what are your intentions. And basic single directive is really avoid using global variables. This is actually very linked to readability, because those are stored somewhere in the program that is kind of imprescrutable. And I'll show a simple example of how to avoid that. And another, again, related aspect is that the indentation, the structure of the code is very important for readability. And this is actually where we will see later that Python, it's actually in a way superior in the sense that it forces you to use proper indentation. In C++, parentheses and semicolon describe the whole structure of the code. So in principle, indentation is optional. And Python actually made a choice early on, this kind of philosophical choice, where indentation is actually part of the code itself. So if you move the location of a piece of code, the scope and therefore the meaning of that code will change. And that forces people to write a little more readable code. This is not true in C++. And by the way, early on, many people criticized the Python because it felt like a weakness to have indentation, basically white spaces, to be part of the semantic of the language. And instead, over time, that proved to be actually a really, really smart choice that never incur into the problems that people would imagine, but instead was very good for forcing people to write good code. So let's look at the basic uh, um, way of building complex data structure from simple ones. And this is where we go from simple variables like an integer to array of variables. In case of here, a sequence of numbers. So this is a very simple syntax. We use a square parenthesis to indicate how many elements of the same type will be stored in sequence one after the other. And also one can use this alias. Can be true in general, not just for array. I can say using array and then declare a type, int 256 in this case. And then if I say array numbers or int numbers 256, those two are effectively the same representation. So let's start looking at the basic use of arrays. So in this case, actually, I'm starting to use functions to avoid creating multiple pieces of code. So in my main here, you see I have the various test cases that I'll try throughout the class. And so the first one here is we start using arrays. So here we'll see how I create a first array. So here I'm going to call test array 1. Let me comment out the other test cases. I'll go to test array 1. I call this function. So effectively, this is kind of my main for these test cases. So here I'm calling a few of those. So here I create two arrays. And here the curly braces are used to initialize the value. And therefore, the number of elements is left implicit. So here I could write test array 3 to say there are 3 elements and initialize this way. So first of all, let me show the program. So I'll clean it and compile. And so here, for example, I could put a 3 and then, oops. And then again, I'll clean and build the solution. And you see that nothing has changed. So the system, by looking at this, automatically understand that the array has that many elements. So let me clean up a little bit. And here we use another function that prints an array. And so what's interesting is that when you create the arguments of the function print array, you give an array. In this case, you don't know how many elements that array contain. This is what in C++ lingo, this would be effectively really a pointer to the array itself. It's not the whole array. So int, arg, and square brackets, it means that this will be referred to an array. And so effectively here we are passing a reference to this array, not the array, not a copy of an array, as may happen with other variables. So we have to specify how long the array is. And then with a simple loop, we print one by one all the elements. So here I'll call test array 1, and that will call twice the function for printing the array. Let me clean up and run the code. And so here you see that we print 5, 10, 15, 2, 4, 6, 8, 10. So this is initialized, and then I call this function twice and execute the calculation. Now, one can do something a little bit more interesting with an array, and so create a two-dimensional array. So let me copy the example from below to above. So I'll switch now to this new test case. I'll now hide the other one. Test array true. First of all, let me compile and see if there is any error. Everything is clean. So here we have a two-dimensional array. So we define as constants the width and the height of the array, of this two-dimensional array. And here you see I can create an array. Instead of saying that has 15 elements, I say that is 3 rows, each of which with 5 elements. And then n and m are going to be the dimensions, the variables I use for looping through that. So as you can see, so this creates the array. Well, let me Oh, we didn't print anything, so let me see. As an example, we want to, for example, print the results, the content of the array. And in this case, then we rebuild. And then we execute. And now we print the 3 rows, 1, 2, 3, 4, 5. So you see that we put the value of the column plus 1 because they are counted from 0. And then in each one, we multiply by 1, 2, or 3. And so 1, 2, 3, 4, 5, and so on. Those are the 3 rows of the array. Notice that we can use the same function that we used before to print a whole array. Here we use it just to print a row in an array. Now here we have the part that violates our rules of style. Those are global variables because they're outside. So what we can do is actually we bring them inside the function itself. And so in this way here, we actually have a good reference of where things are stored. So let's recompile. Notice that the other functions don't need to have access, so there's no good reason to keep this as a global variables that can easily be just local here. And also what's nice is that is allocated inside the function call and then deallocated. So this space is being freed as soon as that's finished. Now you do the execution, and again, you see the result is the same, but the code now it's cleaner. We know locally where everything is coming from. The definition outside could have been farther out at the top of this file. In fact, it could have been even in a different file. That makes it very hard to do any maintenance of this piece of code. And notice also how we are recycling the print function for this array. And so with this representation, we can do single dimensional array, multi-dimensional array. The limitation is that the number of elements in the array is fixed. The dimension is created at the declaration of the array, after which it cannot be changed anymore. And we'll see in a moment how to deal with that. So characters are a type of elements that we use to represent basically a textual character. Effectively, in memory, though, those are numbers limited in range from 0 to 255, so 256 elements. The more modern representation can allow more characters and so on, but the basic one are the ASCII characters. So let me see here. We have a simple now test case for characters. Let me put this function above. So now, instead of having again different programs, I'm using calling different function like this. So here, just an indication of the relationship between a sequence of characters or strings and arrays. So a character is an element of type char, and it is represented with those single quotes. So let me show the compilation on this part of the code. Everything is fine. So here there is a string. Notice that the string is an array that ends with a character /0. This is a special character. This is needed to compensate from the fact that arrays don't store their length. So for a string, the assumption is the first time you hit the character /0, you are at the end of the array. So here we create two arrays, one through the sequence of characters one by one, and one without writing hello directly. Notice that the /0 is not explicitly stored there, and that's where the strings are representations such that automatically the program here will add a /0 character at the end to follow the convention. And so when I print those two strings, the result is the same. And then I'll go through and start changing one character at a time, dealing with that as if it was an array, because effectively it is. In fact, I'm using the second one. So here, for example, if I want to turn hello into hell, I'll take character 0, 1, 2, 3, 4, and I'll turn it into a white space. So my word index 4 is a white space. And so it should write hello twice, here and here. Here it should write hell. Then here I can take a character of index 1, 0, 1, so it should be the second one. I turn into an I, so when I print again, it should say hill. And again, now I can modify this by saying, okay, I can take a character of index 2, 0, 1, 2 is the third one. I make it into a /0, so now the print function believes the string to finish here. And so it should write just hi by changing one character at a time. We went from hello to hill. Obviously, apparently hill, there is really hill and a space. Then simply hi. And here I truncated the string by inserting a /0 in a particular location. So let me run the code. And so here we have the hello. Those two initializations give the same result. And then we change one character at a time. And now the O becomes a space, so we don't see it, but it actually still printed 5 characters, and but it become hell. And then we change the E into an I, so this became a hill. And then the first L became a /0, so it prints hi, and always using the same print function. So obviously this is kind of a very simple test case and shows how to manipulate a string, which is really an array of character. How is it terminated, and how to assign individual character. Notice that a character has the single quote. If I were to put double quote, this would be actually a string. And as you note here, this actually is a string with 2 characters. The first is I, and the second is /0. So if I try to use this code, let me build, and you see I really get an error, not even a warning, because the element here, it's just a single character, and I try to assign 2 characters to it. You see constant char 2, an array of 2 characters. So double quote I is an array of 2 characters, while single quote I is just a single character. So those are the important distinction that actually can quickly, though, create bugs into a piece of code. So here we've seen strings, and of course we can use the standard C in as an input, and those are good facilities, so that, for example, so that one can read elements separated different ways, spaces, new lines, and things like that. Also exchanging sequence of character represent numbers into actual numbers, and so on. So ideally, you want to use the string function from the standard library so that you have more flexibility and read the input, as we have been doing already for a while with the cin function from the standard library. In conclusion, we look very quickly at how to adjust from the fact that the basic arrays in C++ do not allow to know how much information is stored. You see that for string, we have to use the trick of a /0. And most of all, also the length of an array cannot be changed. So there is the vector library that is part of the standard library that creates a generalization over arrays, but with this, all the additional functions to make the array more flexible. For example, here I create a vector of integers, and I don't specify how long it is. I just say this my ints, it's a vector of integers. Notice that the word vector instead of array. Obviously, the implementation underneath, it's array, but with some more additional data structure that, in some sense, you don't want to waste your time rebuilding every time. And then there is a function called pushback that is defined on an array, where you can add a number at the end, and then the system will automatically allocate more space, make a copy in a different location if you run out of space. It is all kind of standard things that C programmers especially have been doing for a long time, initially also C++ programmer, but it's become such a stereotype that just people figure a way to wrap it into a library, make it really efficient in general, so there's no real significant loss of efficiency, and but makes the representation much higher level, much more practical to use. And so, for example, given an array, I don't have to um, uh, keep tracks on myself of how big it is, like we did for the array. For a vector, there is a function called size that tells me how many elements are in that. And so I can query a vector to see how many elements are stored in that vector at that point in time, and they will change over time. So going back to the code, so we can look at how to do more or less similar things, but using a vector. So first of all, we can redefine the function print array. So you see print array needed a length parameter so that we could do the execution. So now if we write a function print vector, we can simply pass the vector, and that will actually contain all the information. So in the loop, I say from n to 0 to and instead of using the parameter, I query the vector with the size, and I will know that, sorry, and I will know the length of the vector, so I can do exactly the same with one fewer parameter. And so this can be much more flexible in general. For the creation of the array, again, instead of having the fixed values at the declaration, I can simply declare my ints as a vector of integers. This is the syntax. This is the syntax used for templates, if you're curious. And so here we see generically a vector, and then we use a few times the pushback function with 3 different numbers, so the vector gets longer and longer. And then we can query the array, know the size. We can check the first element, and then we can actually print the vector entirely. So you look at the value. So for example, here now, let's go back to, let's go back to the main. So we now work with the last test case, and build a solution and execute. And so we have 3 integers. The first one is 5, 5, 2, 3, and the entire array is 5, 2, 3. And so obviously here now I can, what did I do? So obviously here I can add a bunch of other numbers, right? So recompile and execute. And now you see that I have 6 elements and so on. So the number of elements in the array can change, and the function that prints it does not need to know the length of the array as an input parameter. And in this case, they give you a simple solution. So this concludes this discussion of the simple data structures. As I said at the beginning, the key things to remember is arrays as a basic way to extend data structures in C++, characters and strings, how to build aliases, and then obviously the generalization of array into vectors. But more important, as you look at the code, remember those principles of good coding. The code has to be read by humans. And two derived rules is avoid global variables. They make tracking errors a nightmare. And try use good indentation. If you don't have the code indented, fortunately Visual Studio and most other programming environment will do that for you. And thank you for your attention.